Hello guys, tell your friends to join first. Actually, we will start our session by 7:40. So please tell your friends to join first. Okay guys, let's start this session. And right now I'm presenting my screen. My screen is visible, no? Anyone? My screen is visible and my voice is audible, no? It is in proper way, no? Hello? Hello? Anyone can answer. Just a reply. Whether my screen is visible or not. Like, okay, let's start. See, actually, what we are seeing is 1 cross 3 router. Okay. So before going into the session, okay, I need to convey you one thing. See, yesterday someone asked me a doubt. Okay. Like, wait, where is the paint? Okay. Yesterday, someone asked me a doubt like, um, there is there are three flip-flops, So what is the use of three flip-flops? If we are going to pass the data, we can better use one flip-flop itself. No, it is enough. So for that, what I answered is, instead of considering this flip-flop as flip-flop, consider this as a three computers. Okay, so that you can understand like each one will search each data. So for that, our router will direct the data for the particular destination. Like that, I have answered yesterday, but there is a small change in that. Okay, so I don't know whether that person is here in this today's session or not. I don't know, but anyway, I will explain. So if he or she may see this today's session, means it will be clear. See, let's consider this one as a source. Okay, so from the source to our packets. Okay, from source itself, our data will be come out as a packet. Okay, it will come out as a packet only. Okay, so this router will check the packet, and it will check the parity, and it will check the address, and it will routes, that is, it will direct the packet to the perfect destination. Okay, so based on the address, the packet which is sent by the source will be delivered to the destination based on the address. Okay, so there is a small change, that is, because yesterday, yeah, I forgot to explain about that. There is a small change, that is, see, instead of considering this FIFO, okay, so instead of considering this FIFO as a device, okay, so actually it is wrong. Okay, it is not a device, it is FIFO only. But yesterday, yeah, I told like, let's consider it as a computer one, computer two, computer three, like that. There's a small alteration, that's all. Okay, so instead of considering this as a device, consider a outside destination. Okay, consider there is a destination outside. Okay, let's consider this one as a D1, that is destination 1, and this one as a destination 2, and this one as a destination 3. Okay, so this P4 will have connection with the destination. Okay, this is the change. Okay, this P4 will have connection with the destination. Then now you can ask me a thing. Then what is the use of P4? Okay, P4 is a temporary storage. Okay, so P4 will store the packet and it will be delivered to the destination. Even though, see, if we directly deliver our packet to the destination, in the sense we can't store, or our source need to wait for some time if our destination is in process. But if we use FIFO, okay, it will store some data. It can store some data temporarily. So if our destination is doing some process and our source is sending one more data, one more packet, this FIFO have the capacity to store that temporarily. Okay, at the same time, FIFO have signals like full and empty. Okay, so using this FIFO, okay, see this one as full. Okay, FIFO have the capacity to tell whether the destination, that is, whether the destination address. Wait one second. Okay, FIFO have the capacity to tell that the capacity, that is the packet it can hold, no, it is full or empty, that is the FIFO is in full or FIFO is empty. Okay, that status FIFO can tell. Okay, that is why we are using FIFO here. Okay, the purpose of FIFO is, see, this is our router. Okay, this is our 1x3 router. Okay, this is our 1x3 router. Okay, from source to router we send a packet, and from router it will direct to the proper destination based on the address. Where will be the address? Inside the packet, as I told yesterday. The packet, wait here, see in the PDF, in the PPT, see this is our format. Okay, so in this format, it is our packet. So in the packet, in the format, see the first 8 bit, that is the first byte considers a address and the length of our data payload. Then we have data and parity. Okay. So based on this data, our router will send the packet to the correct destination. Okay. So then this FIFO will store that. Okay. Then this FIFO store that packet and then it will send that packet to the destination. Okay. In a proper way, in a one by one proper way without losing any data. Okay. That is why this FIFO is using, and this FIFO have the indicator like it is empty or full. Okay. So what we do, if the FIFO is full, we will stop our data. Okay. We will stop passing our data. We will pass that. Okay. Then if our FIFO is empty, then it indicates like it is empty. If we do some read operation, if our FIFO is empty, it is waste of time. Yes, am I correct? No, because without anything, if we read something, then what we will read if we have a empty storage. Okay, if we need to read something. Okay, so what we are going to read in a empty storage, it is nothing. Okay, so for that indication, there is a FIFO. This FIFO will tell whether it is in a empty or full state. Okay, if it is in full state, like if our destination is here and if we are passing the packet and if our FIFO is in full state, we will pass the data, we will pass the passing of our packets. Okay, so that our destination will process and it will take the next to next packets and it will process, and once FIFO have some space, then it will allow the packets. Okay, so that we can perform a smooth and a data loss without a data loss communication. Okay, we can perform a smooth and we can avoid the data loss. Okay, this is what the doubt asked by a person yesterday, but what actually I told is let's consider this one as a computer 1, computer 2, but it is not like that. We should consider, but it is outside. Okay, destination is outside and the FIFO and the destination will communicate. Okay, this FIFO will pass the data to the destination. Okay, other than that, the remaining and all same only. Okay, this each destination will expect some different data. So at the time, this router will routes, that is, it will direct that data to the particular destination properly. Okay. As of now, is there any doubt as of yesterday's session? This one is the correction. That's why I told. Other than that, is there any doubts or you need any clarity as of yesterday's session? Yeah, you can use comment box also. Okay, there also it is I'm available only. Okay, you can unmute and answer. It is a better way. If it is not possible, you can use comment section. Okay. Okay. So what I explained is understood now, right now, and I will explain the process of each block. Like inside a router, as we discussed yesterday, we have FSM, we have synchronizer, we have register. No, so for each that today I will explain the IO ports. Okay, what are the ports are there and how it will work. So that architecture we will discuss it today. Okay. So as of now, is there any doubts regarding this image and regarding this doubt? As of now, you are clear, no? Or any doubts or any clarity you need, anything like that? Huh? Actually, my screen is presenting, no? See, previously I opened the Paint and we did the example, no? Those things and all visible only, no? So, hello,
It's clear.
hello, visible? Huh? Sorry, I can't hear. It seems. Yeah, you can use comment, no? Just put a message. Yes, that.
Yeah, it's clear. Yeah, the
Okay, okay,
screen was visible. Yeah.
okay, okay, okay then. Okay, let's brush up today once again. Okay, like what we see yesterday. Okay, router is a NOC, that is network on a chip, and we are using 1x3 router. That is 1x3 router in the sense there will be one source, three destination, and the data here will be passed in terms of packets. Okay, And we all know why we are passing routers to avoid traffic. Okay, traffic in the sense it is nothing. See, if we are continuously passing them some data to a particular destination, it should reach the destination in a perfect time. If the destination is full, okay, it should inform to us, like inform to the source that it is right now it is in some process, so it needs some time. Like that, we need some information. Okay, if without any information, if we continuously send some data, so it will occur some congestion in some traffic. Okay, it will end with some traffic congestion like that, or sometimes a data loss. Okay, so to avoid that purpose, we are using routers. Okay, and see, same load balancing reduces congestion and used in many core system. Same only. Okay, okay. See, this is the architecture. Okay, so right now I will explain the characteristics of each block. Okay, right now I will explain the characteristics of each block, and then I will I will explain this particular pin diagram. Okay, I will explain the pin diagrams. Like, see here, for I will explain the pin diagrams for the each block, and at last we will see this architecture, and after seeing this architecture, we can see this FSM. Okay, this is today's agenda. Okay, today's agenda is we will discuss the characteristics of the block inside the router, and after that we will discuss the pin diagram of each block, okay, and its function. After discussing that, we will move to the architecture, and then we can come to FSM, or we can discuss this FSM and then we can move to the architecture. Okay, this is today's agenda. Okay, if it takes some time, no problem, we will extend one session. Okay, no problem, but it should be in a clear way. Okay, if you have any doubts, or if some concept is not clear to you, please ask me, I will clear. Okay, okay then.
I have a doubt.
Yeah, sure.
Uh, so my doubt is, you explained about the concept of FIFO now, right?
Okay,
So let's say that the source is trying to send a packet and the router is sending to destination one.
okay,
So if the destination one is processing and some other data packet,
okay.
so we can store it in the FIFO, right?
Yeah,
In case if the source is sending continuously,
yeah, yeah,
so the incoming data packets we can store in FIFO. Okay, so
yeah.
that is clear. But my doubt is,
Mm, mm.
then why do we need the busy signal? Like how the busy signal is different, because we already have FIFO when
Yeah,
destination is not able to take a new packet.
yeah, okay,
Or in what conditions the destination is going to indicate that it is busy?
okay. See here, actually, where we have busy signal is here, where it is. Actually, destination will not communicate with the router. Okay, FIFO will communicate with the FIFO. That is, FIFO will take charge, and the destination will communicate only with the FIFO. Okay, so wait, we can move to this. Where that? Here. See, wait, I will show you. Okay, see here. In FSM, we have busy signal. Okay, so who tell that busy is in to FSM? Okay, that is important. So when we see here, where actually in this
If you are
FSM,
explaining this concept further, it is okay. We can
no, no,
take it later when it comes.
yeah, yeah, I will explain. No problem. Wait. Actually, see, yeah, here. See, busy signal will come from FIFO only. Okay, so destination will not tell like this is busy. That's all. That and all. Actually, destination will have connection with the FIFO. Okay, so as we see in this diagram, see our destination have connection only with the FIFO. So this FIFO will take care of it, that. Okay, if our destination is in process, then what our FIFO will do, it will store, I think you told like you understood that. Then the busy signals process it. See, if we need to, okay, even in some case, if we need to give some data to the destination, yeah, FIFO can store, but we need some indication, no? FIFO can store, and we need the information like, one second. Just a minute. Yeah, okay. See, yeah, what you told is correct. FIFO will store, okay, the data temporarily, and destination, it will send the packet to the destination, okay. So even though it is sending properly, we need some information, no, because FSM need to process. If it is busy, if the destination is busy, it should hold for some time. It should wait for some time. Yeah, FIFO can hold, but that information we need, whether our destination is in process or it is free or not, like that. So based on that information, okay, wait, in this PPT, see, we need that information. See, wait till empty. Okay, if our FIFO is like it is full, okay, it need to wait for some time. Same in the destination. If it is busy in some other work, then our FSM should know. Okay, it is in busy state. Okay, we need to wait for some time, like that. So in that case, we apply busy. Okay, but other than that, what you told is correct only. No problem. FIFO will store some data temporarily and it will send to the destination. If destination is in process, that is, if it is working, then FIFO can store it for some time if the destination is busy. But that indication that we should know, okay, our destination is working, so it is in busy state. That state we should know. Okay, but we will discuss. No problem. See, in this diagram we have no busy signal in the FSM. See here in FSM output side we have busy, and we will discuss about that. Okay. So as of now, that busy, that use of
Yes,
that busy is clear or still need any not clear like that?
it's clear. Thank you.
Okay. But anyway, we will explain. Okay. It. Where to okay. See, what what it is, as I told, okay, that busy signal is indicate FSM is actively processing a packet or not. Okay, so for that purpose only. Okay, so our FSM is actively performing. That is, yeah, it is processing and it is ongoing process, like that, for some indication. Okay, that busy signal is used. Okay. Okay, then where we are? Okay, here we are. Okay, let's come to this pin diagram first. See, as I told yesterday, clock and reset is a global signal, no problem. It is for a synchronized way. Okay, it is for a synchronized process. Okay, our process would be in a synchronized way. For that, we are using clock and reset. Okay, so apart from that, and see here in this diagram, there is arrow mark also. Okay, actually, we discussed this yesterday itself, but once again, no problem. We will discuss. Okay, so first our data, see our input data is passed. Then before reaching the destination, our router should indicate that data is valid or not. Okay, so for that purpose, here what we are doing is, okay, our data is valid, like that we need to convey, okay, to the destination. Okay, from source it will convey to the destination that the given data is a valid one. So you can accept that. For like that, it will give a signal. Okay, that is called as a packet valid. Okay, then we have a uh, error and busy signal. See, here we have error and busy signal. This is from destination. It will come to source. Okay, and then we have read enable signal. Where it is here in this? Yeah, it is here. Okay, we have read enable signal. So where this read enable signal will come from is, it will come from destination. Okay, what read enable signal is for, actually, before sending a packet, our destination should know. Our destination uh, will tell whether it is ready to get that packet or not. Like that, it will convey to us to the source. Okay, so for that purpose, we need read enable signal. Okay, Then we all know data out. Data out in the sense, yeah, we will get one input data and it should be delivered to any of the three output data, any one, okay, any one of the three output data. So before getting the data, okay, to the destination, that destination should tell like output valid, okay. Our that is before moving this out data out, our there is one more signal, that is valid out. Okay, the process of valid out is it is from source to destination. So it will tell, okay, the coming output data. See, you no need to confuse with the packet valid and the valid out data. Okay, packet valid is the generally, okay, generally if we see means before starting the process, it will check the packet and it will give the signal, okay, this packet is a valid one. Okay, but after the packet is valid, inside we have some operation, no? So after that process and all, we will send the data, okay, out to the particular destination. In that case, if our data out is ready, we should have one more indication, that is valid out. It is from source to destination. It will tell like, okay, the output which is coming is a valid one. So the destination can accept that. Okay, like that, there is a signal that is called valid out. Okay, then there is error and busy signal. So as we told, error is if the destination will receive some packet, no. So if the packet is mismatched or if it is not receiving any packet, in that case it will throw a error. Okay, in through the error signal. Okay, and if it is busy, if it is doing some operation. Okay, if our destination is doing some other works, so for indication it will tell, okay, I am busy right now, so I can't accept the data further till I complete my work. So for that purpose, it will convey a busy signal. Okay, this is what this pin diagram is of. Then actually all this process comes under a network layer. Okay, and we pass data in terms of packet. This is important. Okay, then this is packet format. As I told yesterday, the first 2 bits is for the address and the remaining 6 is for length of the payload. So if our length is 3, then we have 3 set of data, that is data 1, data 2, data 3, and each data is of 1 byte, that is 8-bit. Okay, finally we have parity to check whether the data is properly received or not. For that, the same data is properly received or not. For that purpose, we use parity, okay, for checking purpose. And see here, this is from input side. And you can notice one thing. See, when the clock is high, okay, when the clock is high, our reset is in low state. But when our clock is low, see, what you should know here is our reset is a active low. Okay, so whenever our clock is high, this reset is low. It means the reset is performed. Okay, because of active low. Okay, then after in the next clock onwards, the reset is high. That is, the reset is in off state as of our knowledge. Okay, because it is active low. Okay, so see, as I told in the pin diagram we discussed, no, this packet valid should be high first. Okay, so since this packet valid is high, we are passing our data like first one is header. Okay, so see in this header, okay, someone has to know what is the use of busy signal. See, the header is first we are passing header. So since our destination is throwing a busy signal, okay, so it should indicate like I am in busy state, like that. Okay, so in that state, our header will be that transfer will be expanded. Okay, why it is expanding? Because yeah, we can't further we can't move our payloads and all because our destination is in busy state. Okay, it is doing the process, some other process. So after busy state is low, we are passing the payloads. Like we are passing payload, then parity. Okay, so here you should note one thing. So for checking parity, packet valid should not be high. Should not be means it may not be high. Okay, it is not necessary. Okay, that is what they are telling here. Like after sending the payload, for checking the parity, the packet valid uh, may not be the packet valid may not be high. Okay, it can be low. Okay, it is not necessary. Okay, that is what they are telling. And after that, see here the result. Okay, the error result. Okay, see what it is saying is the received data, okay, the received packet is error. So if it is error, our error signal will throw this message. Okay, what it means? The parity mismatch. Okay, PM means parity mismatch. Okay, parity mismatch in the sense the data which we sent and the data which received by the destination is mismatching. It is not same like that. Okay, it is from input side. And see, this is from output side. Okay, as I told before, first we are resetting, then packet is valid, and we are passing the data. And see in the output side. Okay, as I told you, see the output is valid to receive when once our packet payload is ready. Okay, see it is not considering header. Okay, once our payload is ready to reach the destination, our valid out will be high. Our valid out signal will be high. Okay, indicating that the coming payloads are valid. Okay, it is valid to receive or it is valid to deliver to the destination like that. Okay, so once the read enable is high, the data out will be delivered to the destination. Okay, then see here this parity also here. Okay, everything will be delivered. Okay, so as I told you before, for checking this parity, our packet valid should not be high. Okay, it is not necessary. Okay, so when our read enable is high, our data is delivering here. Okay, to the destination side. Okay, that is what data out is. So this is what the waveform actually here. This is the process. Okay, so is there any doubt in these two? From these two, is there any doubts? No doubts, sir. Okay. See, as we discussed in the yesterday's session, there are four components. Okay, one is P4 and one is FSM and one is synchronizer and one is register. Okay, so for each component there is a purpose. Okay, for example, if register, see register is also temporary storage. Okay, so in that case we should not compare that register with the P4. Okay, so P4 is also a temporary storage and register is also a temporary storage. We should not compare like that. See, register have its own process. Okay, in register we will check the parity and we will check the parity error and all. Okay, is there any error? Like this process and all comes under register. Okay, but when it comes to P4, it will tell it is full or empty, like that it will tell. Okay, yeah, actually the main thing is it is also temporary storage. P4 is also temporary storage. A register is also temporary storage, but the characteristics will change. Okay, so we no need to confuse like this is also storing, that is also storing. Then we can use any one of this. No, why we are using separately like that? So the answer is the characteristic differs. Okay, it have its own process and register have its own process. Okay, okay then. See, as we discussed in the starting of the session, the P4 processes, it will deliver the packet through the destination. Okay. And if our P4 is full, that is, if our destination have some other works and it is in full state. Okay. That is, it can't accept any other data. The P4 will throw a full. Okay. P4 full. Okay. Or if it is empty, actually, see, FIFO full and FIFO empty is for two, we can consider this for mainly two process. Okay, one is for read operation, one is for write operation. Okay, so before writing something to a FIFO, okay, FIFO will deliver to the destination. It is the second part. Okay, as of now inside the router. Okay, so before we are going to write something, we should check that whether our FIFO is empty or not. Okay, because if our FIFO is full, we can't write anything. Okay, for same for read operation. Okay, before we are doing some read operation, we should check the FIFO that whether our FIFO is full or empty, because if our FIFO is empty, we can't read anything. Okay, so for that purpose here FIFO is used. Okay, so it will save some time now before if we are doing some process and if it is full or empty, so that signal, if we know it priorly, then we can process according to that. Okay, My voice is visible now. Hello. Sorry, my voice is audible now, and my screen is visible now. Is there any problem with that? Yeah. Okay. Okay. Next one is synchronizer. Okay. So the use of the synchronizer. Why we need synchronizer? See, if there is in FSM we have different states. Okay, and register should process the parity, and it should get the data in, and it should deliver the data to the particular destination. Okay, but the all this data should be in a timely way. That is in a proper time, in the correct time, correct signal should be asserted. Okay, for that purpose, we have synchronizer. Okay. For example, if our data is detected, that is, if our address is detected, then what will be the next step? Next step will be data load. That is, load first data. Okay. So after receiving the address detect. Okay. After we are detecting the address, we should load the first data. So the first data signal should be asserted. Okay. So it should be done in a perfect time. Okay. So perfect time it should be done. For that we need a synchronizer to synchronize the actions. Okay, involved here. Then we have register. As I told you, register is for it is also for storing temporarily store the packet, but it will not only store, it will check the parities, and if the parity is it is mismatching, it will throw a error. Okay. See, wait. See here, now register. See, it is having a error signal, and low packet valid means nothing. See, it is also a packet, but with some minimum data. Okay. Actually, a packet will contain a full data. Sometimes we have some minimum, very minimum data. No, it will be come under packet low packet valid. So for example, how we take is, see, if we are taking if our data payload length is 1 byte. Okay, our data payload length is 1 byte. So we have uh, two datas. Okay, for example, wait. Okay, let's consider this frame format. Okay, see, in this frame format. Okay, in this frame format, let's consider we have two data, okay? That is data 1 and data 2, okay? Okay, actually, in the packet which we take for our example is its length is 2, okay? That is we have 16 bit, that is 2 byte. Then we are passing it, okay, from a source to destination, okay? So our packet size is this only, but if we have two more extra bit, okay, if we had two more extra bit as a information, okay, which need to be passed from a source to destination, what we do is actually our FIFO is full now, okay, let's consider like this. Actually our FIFO is full now, so that 2 bit should be wait for a particular amount of time. Then if our FIFO have some space, okay, then that 2 bit will be passed. So that is low packet valid, some minimum amount of data, okay. I am telling just the only one example. There are plenty of example for that, but basic idea is low packet valid in the sense very minimum amount of data will be passed, okay. Okay then. Okay, as of now, is there any doubts? Everything is clear or any doubts in the signals and all, router input protocol, output protocol, like that and all signals there, no? So is there any doubts in this signal? Anyone? If there is doubt, you can ask or you can put like you can tell like no doubts or clear like that, so that we can move to the next topics. Okay, no doubts, huh? Okay. So we are moving to the next topic. Okay, that is our router top level FIFO. Okay. When it comes to FIFO, now we are going to explain pin diagram for each block. Okay. So when it is comes to FIFO, okay. So as we discussed, for every block there is a particular signal. Okay. But at last we will connect with there is a connect with each other. We will see in the final block. Okay. We will see in the architecture about that. Okay. So now we are going to discuss about router FIFO. Okay. Okay, see, what is the use of FIFO? This module likely act as a temporary storage. Okay, we discuss no. It will be a temporary storage before sending to the destination. We will receive the packet in the FIFO. Okay, and it is a simple storage means what is a buffer. It is going to give whatever it is received. It will going to give the same at the output side. Okay, and incoming packets. Okay, then there are signals like see in input we have data in. Data in is of 8 bit. Okay, 8 bit in the sense, see, in this packet format, everything is of 8 bit. That is 1 byte only. That is they are telling here. Okay. That is input data. Input data is of 8 bit. And we have a class. See, LFD in the sense, load first data. Okay. If we have a first FIFO, okay. And now only we are going to load the first data. This signal should be asserted. Okay. It will come with the header also. Okay. Because when the first signal come, see here in the format, then the first signal come. Before that signal, what is there? There is a header. This is called as header. This length is equal to n. Then we have channel. No, this byte, this 1 byte is called as header. So in the first data, why we need indication for first data in the sense before that first data or with that first data accordingly, this header also comes. Okay. So for that purpose, we are using here IFT state in the sense load first data. Okay. Then read enable. We all know if the read enable is high, then only our router can read, okay, that packet, okay, or our destination can read the packet, okay. It's like that only. If the read enable is high, then only our destination can read the packet. Then we have reset. We all know. Then see, there is two type of reset. One is soft reset. One is hard reset. Soft reset in the sense, if we need to stop, if we are sending some data and if that data is not yet responding, okay. So if, like that, if you are sending an address and we are sending a input data and there is no response, that is the data is not yet received from the destination side, our process that our clock cycle will see for around 30 clock cycle, our router will wait. Okay. So after 30 clock cycles, it will reset. Okay. It is one of the example, one of the cases like that, but it will change to the different routers. Okay. But basically what happens is it will reset in the sense it will go to the high impedance state. Okay. High impedance state in it means it will not directly make all the data 0, but as of now it will be stopped. Okay. The transaction, okay, that bus will pass the data from the packet from one place to another place. No, that transaction will be completely stopped. Okay. And if we pass the soft reset, it will go to the high impedance state. For example, see in this code, what you see here, it is an example code. Okay, this is what we are going to see here. See in the reset. Oh, sorry. See, this is a reset. See here, the second one, that is the 17th line. Else it's soft reset. So it's soft reset. If we done soft reset, see, all the bits are in high impedance state. That means it will not go to 0. Okay, suddenly it will not be 0, but everything will be stopped. Okay, every transaction will be stopped. Then our bus will have the connection. It will move on to the next process. Okay, it will move on to the transferring of next data. Okay, so for example, if our destination is there, if you are passing some packet to the destination, but there is no response till now in the destination side. Okay, if you are passing a data to the destination one, but after passing the packet, okay, data, okay, it is packet. After passing the packet, till now, if there is no response, it will automatically, what it will means, it will soft reset. Okay, it will do soft reset. So soft reset in the sense the process will completely stopped. Okay, so now the bus will not process the packets. Okay, if the if our destination 2 needs a packet right now, some other packet, the bus will take care of this second destination and it will continue the process. Okay, so whenever if the destination 1 is now ready to accept the packets, then it may, okay, then it may accept the packets further. Else, after some time, we can do hard reset itself. Okay, this is what the difference between soft reset and hard reset. See, once again, I am telling clearly, soft reset in the sense, sorry, hard reset in the sense, reset done by us. Okay, if you are doing reset, then the packet and the people, the data inside, okay, the packets completely will become 0. See here, the output data is 0. Okay, but soft reset is not done by us. Okay, if we are sending a packet to the destination and for a particular period of time, there is no response from the destination side. Okay, for a particular period of time, for example, in some case it is of 30 clock cycles. Okay, so for around 30 clock cycle, if there is no response from the destination side, it will automatically do the soft reset. Soft reset in the sense it will not make the data to 0. Instead, all the data will be moved to high impedance state. That is, it will be stopped. Everything will be stopped, and the bus process will not be act there. Okay, the bus will not be in control at that time. It will move to the further processes. Okay, so there are two cases. Once our destination is ready to process the packet, which it is stopped, then this soft reset then this high impedance state may removed and our as usual packets may delivered. Okay, or else if it is in high impedance state and it is of no use, now the destination is not accepting the data, now we can do hard reset. Okay, there are two possibilities. Okay, so this is the difference between soft reset and the hard reset. Okay. We are seeing our FIFO. Okay, this is what soft reset is and write enable. Okay, so if we need to read some data, for example, see in Google Chrome, what we are doing, we are searching something and we are receiving something. Same here. Okay, if we need to read something, we are going to enable the read. If we are going to write something, we are going to enable the write enable signal. Okay, and see our FIFO have two signals, that is empty and full. That is, if our FIFO is full, it will assert this full signal. If our P4 is empty, it will assert the empty signal. And this is our data out. That is, in this, it will going to pass the packets to the destination. Okay, it will transfer the data to the destination through data out. Okay, and then router FSM. Okay, so FSM basically it is like a brain. Okay, it will control. Okay, if we are at present we are in address decode state, then what is the next state? Okay, then what is the process after the next state? If we are getting some particular condition right now, which state it should be moved. Okay, right, like that, it will control the whole process. Okay, it is like a brain which monitors the input data and FIFO status and all. Okay, so and controls when and where data to be delivered and when and where that the data to be routed. Like that, it will. Okay, this is the use of FSM, finite state machine. Okay, so the use of this is it will manage the states and it will enable. Okay, it, for example, if we are passing the first data. Okay, so what we are going to assert, load first signal. Okay, load first data, that signal will be asserted. Okay, so who will take care of that? Our FSM will take care of that, because previously it may be in address decode state. So after address decode state, what is our next state? It is IFT, that is load first data. And FSM have that information, and according to that information, it will assert the signal in the register. See, in the register we have IFT here. Okay. So according to that information, FSM will assert the signal in the register. Okay. This is the use of FSM. And FSM also have, see here, here the data is of 2-bit. That is the LSB. That is bit 0 and bit 1. Why? In the sense, it needs the information of the address alone. Okay. Our FSM no need the data information. That is what the actual payload we are going to pass. Our FSM no need that information. What information our FSM need is, it needs the information of the address. Okay. So as we saw in our frame format, see here, the LSP, okay, the first 2 bits coming from the LSP, that is 0th bit and the first bit is for address. That is why we are passing address here in this FSM. Okay. Then clock, you all know, it is for a synchronizing purpose. Then MT0, MT1, MT2 in the sense, it will indicate whether the FIFO1 is empty or not, FIFO0 is empty or not, and FIFO2 is empty or not, like that. Then, see, you can notice one thing here. We have 3 empty signals, okay, for FIFO0, FIFO1, FIFO2, but for FIFO full, we have only one signal. Why? In the sense, see, why we while we are doing reading operation, okay, that time what we need the information of the FIFO whether it is full or not. And while we are writing something, previously we will be fixed. The target will be fixed where we are going to write and what we are going to write. The target will be fixed. Okay, so it is from source to destination. No, so our source, before sending a packet from a source to destination, the target will be fixed. Okay, so our FSM will know, okay, it is coming from a FIFO1, FIFO2 or FIFO3. Okay, see, one more thing is our FSM no need that information like FIFO full for first one, FIFO full for second FIFO, third FIFO, like that and all. It no need information, because while sending packet from the source itself, the target is fixed. Okay, so based on that, this FIFO full will be asserted here. Okay, but when it comes to empty, we have separate signals. Okay, for FIFO1, FIFO1, FIFO0, FIFO1, FIFO2, we have separate empty signal. Okay. Okay, then as I told you, low packet valid is here. Okay, I told no, if some minimum amount of data is passed, then this low packet valid should be asserted. Where you can see this is, see here in the FSM, see this is load data. Okay, and our how we load the data based on the capacity. Okay, if our FIFO, that is if our FIFO have the capacity of 2 byte. Okay, then we will pass if our information That is, if our packet which we pass is of 2 byte, it is okay. It can hold that and it can pass. But if it have 3 byte, what happens? Suddenly see here, from low data to it is going to the FIFO full state. Okay. So now FIFO is full. Okay. So till the destination is processed and we are getting some space in the FIFO, the same state will be repeated. That is why they are putting like this. Okay. So after that, if we get some state, okay, that is after that, if we get some space, see here in the between the FIFO full state and load after full. See the signal is FIFO is not full. Okay. How FIFO is not full? Because whenever FIFO is full, it will come to the FIFO full state, and if we have some more data, it will wait until we get some space. So after getting some space, now our FIFO is not full. Okay, then we will load after full. Okay, if that load, okay, if that loading data is somehow a low packet valid. Okay, that is we have some minimum data. Then see here, this low packet valid will be high, and then we move to the load parity and further process will be continued. Else, it is not a low packet valid. Actually, it is somehow a big data. Okay. So after our FIFO full, we will wait for some space. Okay. After getting some space in the FIFO, we check whether the data is minimum or we are once again we are going to load some huge amount of data as before. Okay. So to check that state, see here, if low packet valid is, if it is not the low packet valid, where we are going to move, we are once again going to move the load data, move to the load data state. Then once again, this process will be continued. Okay. This is why we are using this low packet valid. Okay. Then parity done in the sense, our parity is done or not. That is, our parity is properly checked or not. Okay. It will be given to FSM, where it will be given is, wait, see this architecture and see this register. There is a parity done signal and it is moving to the FSM. It will be given to the FSM. Now you may have a question like, why we need to pass this to the FSM? See, let's consider this FSM. See here. So when we are passing this, okay, once our parity is done, we need to go to the address decode stage once again. Okay. So if that parity done signal is passed to the FSM, then it will reset. Okay. It will reset the router. Then once again, it will ready to get the next packet. Okay. Then once again, address decode, then load first. This same process will be followed. Okay. That is why we are sending the parity done from the register to this FSM. Okay, then packet valid, then reset n, then we have soft reset. Okay, for each FIFO we have soft reset, different soft reset. Okay, so at the output end we have busy. Okay, if our destination is doing some more, our FSM will pass a busy state so that all the operations which is going to that all the packet going to that particular destination will be halt. Okay, then direct address. See, once again, I will show you this architecture. See, in this architecture, note this FSM, and it is 1, 2, 3, 4, 5. Note this fifth signal. It is direct address. So once our decode address is once our FSM is detecting some address, okay, it will start the decode address state. Okay, at that time, that direct address signal should be go to this register. Okay, now register will come to know that okay, some address is detected. Okay, so based on that, next payload will come. So after that detect signal, what will come? Once our address is detected, what will be the next step? Next step will be load first data. Okay, so here the large signal in this FSM is load first data. Okay, so according to this load first data will be moved to this register and it will be asserted. Okay, now our register will load the first data. Okay, this is what the connection. Okay, based on this only we should understand. So where we are in this FSM. Okay, see FSM full state, and LAF in the sense load after full. We saw FSM, no? And there is a state called load after full, no? That is what here it is. Okay. This is pin diagram. That is the actual implementation of the FSM. Okay. Then LD in the sense load data. Okay, load data. Then as I told, LFT means load first data. Then this is what is this means? Register reset, particularly for that register alone. Okay. If we need to reset that register alone, okay, the packet inside the register alone, we will use this register int. Okay, that is reset inside the register. That is reset int reg. Okay. Then write enable for the register. Okay, if our register is going to write, we are going to write something in the register, then write enable will be given from the register to FSM. Okay, see here actually in this diagram, in this architecture, see they have given like that arrow mark. Okay, that indication where the signal is coming from and where it is going to, like that. Okay, so this write enable is here. And sorry, this write enable is going to the synchronizer. Okay, synchronizer will receive this write enable from the FSM. So based on that, it will move to the register and further process will happen. Okay, and the next is synchronizer. Okay, so as we told before, what is the use of synchronizer? It will do the process in a timely manner. Okay, so in a right way where our signal should be asserted and when it should be asserted, it will be take care by the synchronizer. Okay, so this block is responsible for synchronization and controlling the signal generation. Okay, it will generate the correct signal at correct time. Okay, so here in synchronizer also we have some signals. Okay, see here also we are passing only address. Okay, data in, that is 0th bit and first bit. Okay, so as of now this FSM and the FIFO is understood now. As of now, is there any doubts or you need any clarity? Okay, I will discuss these two also. Okay, after discussing this router, this synchronizer and this register, you can ask your doubts, we will clear, and we will move on to the next one. Okay, after clearing your doubts, we will move on to the next one. Okay, okay, see here, this is synchronizer, and in the synchronizer we have data in. We have 2 bits, that is the address bit. Okay, and we have clock direct address. As I told you, no, see, once we are passing the, our FSM will pass the direct address signal. Okay, see this architecture. See here, in the fifth signal in the FSM, there is direct signal or direct address. Okay, it is moving to the register. Also, it is moving to the FSM as well. Sorry, synchronizer as well. Okay, so the synchronizer, once it receives the direct address, it will synchronize. Okay, so after the direct address, what we should do? We should load the first data. So when we should load that first data, and after that, so for that, what should be enabled? What should be the condition to be checked before that? This all should do in the correct time, in the correct way. Okay, actually synchronizer is to do the process or to assert the signal in the correct time. Okay, so in the correct signal will be asserted in the correct time. For that purpose, synchronizer will be used. Okay, and where we are in the synchronizer. Okay, so here also we have MT0, MT1, MT2, everything in synchronizer. Everything is for the synchronizing purpose. Okay, once the synchronizer came to know that one of our FIFO is in empty state, then what will be the next signal? Okay, what will be the next? It will be obviously our read is going to perform. So it will enable the read signal in the correct time. Okay, that is what the synchronizer is of. See here, we have MT0, MT1, MT2. See, in the before, in the FSM, we can see in the FSM, here we have only one FIFO because it no need that information. Okay, but here in the synchronizer, it needs the information. Okay, either which of the flip flop is, which of the FIFO is full. which of the FIFO is full, which of the FIFO is empty, that all the information this synchronizer need. Okay, then only it can assert the next signal, okay, in the correct time. Okay, then we have three read enables, then we have reset, write enable for the register. Then at the output side, we have write enable, then we have FIFO full, then we have see. So this is full, okay. So it will indicate that FIFO is full. So based on that, this FIFO signal, this FIFO full signal will be sent, okay. We'll see where this FIFO full signal is going. See here, if you are receiving or synchronizer, it is here, okay. See the arrow mark. Let's consider in this synchronizer, consider this full 0, okay, or consider this full 2, okay, because it is near, no. See here in this P42, there is a full 2 signal. It is coming, okay, to the synchronizer. See this arrow mark, it is coming from P4 to the 2 to the synchronizer, okay. So after getting this P42, this synchronizer will came to know that, okay, this P42 is full now. So what it will do is, it will assert a P4 full signal and it will move this signal to the FSM. So now what it will do, our FSM will come to know that, okay, our FIFO is in full. So it will turn this full state, that is our FIFO is in full. So it will give this to this register. So this register will come to know that, okay, our FIFO is in full state. So what it will do, it will make this valid off, or it will wait for some time, okay. It will wait for some time until our this P42, we are considering, in our case, we are considering this P42, no? So until this P42 have some space, it will maintain, it will wait, okay? Once after it have some space, it will send the data, or it is, our process is done. That is, all the packets are received properly. It will go to the address, decode address state once again, okay? Okay. Then we have valid out here. Everything is for synchronizing purpose only. Then finally register. Okay, register we have 8 bits because it is going to pass the data, actual data to the FIFO, and FIFO also have the 8 bit. See here, our FIFO also having the 8 bit. That is, yeah, this will contain the actual data because our FIFO is going to pass the data to the destination. So where this 8-bit data, which is D in the FIFO, where this D in is received, from where it is coming from? It is coming from this register, okay. See, this register is giving data, okay. Wait, see in this architecture, see this red one, okay. It is in dark red, no, it is our data, okay. This data is given based on the address, based on the header. It will detect the address and it will give to the any of these 3 FIFO, okay, any one at a time, okay. It will detect the input data, and based on the address, it will deliver the input data to any one of this FIFO, okay. So that is why here we have data, okay. Then here we have error, okay. When there is a parity mismatch, okay. So now you should note one thing. Our register blocks will take care of the parity mismatch, okay. So when there is a parity mismatch, error will be produced by this register, or that parity is matched, parity done will be produced, okay. Then low packet valid, if we need to pass some after our FIFO is full, and once again our FIFO have some space and we need to pass very minimum amount of data, this low packet valid will be asserted, okay. And see this input side, we have 8-bit data, clock, detect address, we have FIFO full state, and then we have load after full state, we have load data state, we have load after load first data state, then we have packet valid and reset inside the register, that is reset int register, okay. These are the pin diagrams, okay. So now please ask, if you have any doubt in this pin diagram or architecture, you can ask. Yeah, after that we will discuss this FSM and architecture finally. But before that, if you have any doubts, please ask. Is there any doubts as of now?
Like there you use FIFO full, no?
Only one
Okay,
FIFO full. Can you explain once that I've not understood?
okay. Right. We will go to the architecture. Okay. See here in the architecture. Okay. See our if let's consider our our FIFO2 is full. Okay. Now our FIFO2 is full. So this full 2 here in the FIFO2 there is a full 2 signal. No, it will be asserted and it will be moving to the synchronizer. Okay. So see here our synchronizer have a FIFO2 full that is our synchronizer have the full 2 signal and this asserted signal will be moving to the synchronizer. Now our synchronizer came to know that okay, FIFO2 is full. Like that, it will came to know. Then what it will do? According to this, it will assert the FIFO full. See the first signal of the synchronizer. There is a FIFO full. It will assert the signal and notice that this FIFO full is going to the FSM full. Okay. So when this FSM receives this FIFO full, what it will do? It will send the full state to the register. Okay. So why we are using only one FIFO full in this FSM is there is no need because our synchronizer knows no which of the FSM is full. So it will just send this full to this full signal, FIFO full signal to the FSM. So FSM will do the same process. See, even though if our FIFO 1 is full, if our FIFO 0 is full, if our FIFO 2 is full, what our FSM is going to do? It have some set of state. Okay, it will going to pass or it will see here in the FSM. What this FSM is going to do? It obviously it is going to pass from one state to another state. It is going to transfer from one state to another state. Okay, so it no need that information. Okay, any of the FSM is full. Obviously, it is going to pass that. It is going to transfer from one state to another state. So for that, here this FIFO full is enough. Okay, this is what this operation is of. See, next to this FIFO full state in the FSM will be asserted and it will be going to this register. So according to this FIFO full state, our register will wait for some time or it will halt or it will make this valid low for some time. Like that, some process will be performed. Okay. This is what your doubt or something else?
Yeah, like I'm asking at a time, two FIFO can be full now. Like if the data is passing, so the
Yeah,
FIFO
yeah,
zero also full and one also full. But through the synchronizer, only one full signal will go now.
yeah. Okay. So
Okay,
that
so
is what I. Yeah. Please continue.
that is my doubt. Like that time, how it should handle? Like which signal will
Okay.
go to FSM? So,
Okay. So which signal will go? Before that, we should come to one thing. See, our input data, okay, will be passed to the output data any of one FIFO at a time. Okay. So our source will give a packet. Okay. So it will be received to the destination, any one of the destination. So obviously any one of the destination will be high. In your case, if after receiving, see if our FIFO 0 is full first and then if our FIFO 2 is full first, obviously our FSM will consider this which FIFO is done first, it will consider that. Then it will move to the next FIFO. Okay. But actually what happens is as we discussed before, our source will be transferred. Our source will transfer a packet. Okay. Our destination, any one of the destination will receive that packet. Okay. So our packet will be delivered to any one of the our packet from the source will be delivered to any one of the destination at that time. So maximum any one of the FIFO will be full at a time. If in case if two FIFOs are full at a time, then it will work with one first, then it will move to the next one. Okay. Am I right? You can understand or still any clarity you need?
since like one by one, it will go. So
Yeah, it will go by one, but maximum it won't happen because our source is delivering. No, it is going to deliver to any one of the destination only. Okay. After completing that, we may receive or it will be like one by one like that. Okay. This is what actually happens. But our synchronizer will know which signal is that is which of the FIFO is empty, which of the FIFO is full. that will be known by our synchronizer. Based on that, this synchronizer will assert the signals. Okay, that is why we are using synchronizer. I think now we come to know that the importance of synchronizer. Okay, so this synchronizer will take care of that. Okay, now you understand, no, or still?
Yes, got it.
Okay, okay. Hmm. Is there any other doubts? Any other? Okay, actually today, if we take this FSM, actually we will come across with this FSM, router FSM, and we will refer this architecture once again. Okay, no problem. But see this four pin diagram. No, is there any doubts in this? If you have any doubts, we can clear here itself and see the design. Okay, here verification, as I told you, it is done by UV. Yeah, okay. Any doubts as of now in this session? Did come across some slides, no, like the pin diagram, and not in this session, in the previous session also, in the overall. If you have any doubts, please ask now. No doubts, sir. Okay. So now we can move to this. We can move to this architecture. Okay. Okay. See, we discussed everything, the signals and the characteristics of each block we have discussed, but once again we will discuss. Okay. Okay. We will take the paint. Hello, my voice is audible, no? Hello? I think I got hurt right now. Think. Yeah, my voice is audible, no? Wait, I will share my screen once again. Actually, I got disconnected. Sorry for that. Are you all got disconnected or only I got disconnected? Hello?
No, for us, okay.
You also got disconnected, huh?
No, not disconnected. Present only.
O- Okay, okay, okay. Okay, then we will continue. No problem. Okay, I am sharing my screen. Okay, see here. Let's consider a source. Okay. See, yesterday someone asked some doubt, no? So, in that doubt, there is some small correction, and I don't know who asked that. Like, wait here. Okay. See, yesterday, once again, I am coming because here now I think everyone is present here. So, someone yesterday asked some doubt why we need FIFO. Three FIFOs, we can better fast, we can use one FIFO and we can pass our packets from that one FIFO to the three destination. So what I told is, let's consider this FIFO as a computer, three computers, and now you can connect with the source like that. I told actually it is not like that. There is a small alteration, that is the destination is separate. Okay, it our FIFO is not destination. Our destination is separate. Our FIFO is going to communicate with the destination. Okay, that is what the change is. Okay. remaining and all same. Okay, we may expect some different data, different time. For that, we need some three FIFOs to communicate with three destination. But this destination is separate from FIFO. Okay, that is what I need to tell here. Okay, okay. Now come to here. See, we have a source. Okay, then here we have three destinations. Okay, so see, our source have a data. Okay, that data, only one data. That one data will be shared to this FSM and to the synchronizer and to this register. Okay, wait, I will increase this size as well. See here. Okay, this is our source. Okay, so the data from source will be accessed by this FSM register synchronizer at the time. Okay, so now let's consider. See here, let's consider our register. Okay, see there is a packet valid. If the packet valid is on, what it is going to do? It is going to pass the address first. Okay, so where we are getting our address? See here, packet valid is in everything. Okay, see here in this FSM also there is packet valid. Okay, for our understanding, first let's consider this FSM. Okay, it will be easy. Okay, let's consider FSM and see here. First thing is if our packet valid is high. Okay, what it is going to do? What is our first state? According to the FSM, let's go to this PowerPoint and see here. And please, 1 second, wait. I will check whether the recording is happening. Okay, can anyone answer? This recording is happening for you? Is there any time is showing like 1 hour like that? Anyone, please? Actually, I don't know because I reconnect. No, actually, recording is happening or not? Is it showing any time like 1 hour like that? Anyone, please?
Yes, it is showing 1 hour 26 minutes.
Okay, thank you. For me, as I reconnected, it is showing like 3 minutes like that. So I confirm. Okay, okay. Let's come to this. Okay, see this. What is the first state? It is decode address. Okay, see decode address. So from decode address, we are moving to load first data. When we are going to move load first data, if our packet is valid and if our data in, okay, it is some address. It is showing like if our data in is 0th location, it is pointing to the 0th location. That is in the sense, if it is pointing the 0th destination, and if our FIFO is empty, okay, then we are going to load the data. Or if our FIFO is full, what we are going to do is, if our packet valid is high, and if our data in is showing the first destination, sorry, and then see here, if our FIFO empty is not applicable, that is our FIFO is not empty, it will wait till our FIFO get empty. Okay, see here, if our FIFO is empty and the address is 0 or 1 or 2, any destination, it will move to the load first data. Okay, so for that purpose, see here, first FSM will send this direct address. Okay, see here, it is sending the direct address to the register. At the same time, it is sending the same signal to the synchronizer. Okay, so it is sending the same signal to the synchronizer. Okay, so why it need to send to the synchronizer? Because then only our synchronizer will help to assert the next signal in the proper time, in the correct time. Okay, there should not be any mismatch in the assertion of the signal. For example, if we need to assert the signal load first state, okay, here in the register, if we need to assert the signal, we should assert once after we are in that particular state. For example, after we are asserting this direct address, okay, what is our next state? Our next state will be load first data. Okay, see this last signal of this register. Load first data state. Okay, so once after asserting this direct address, we should assert this load first data state. Okay, so it should be done in the correct time. Okay, so after that, what should happen is we should be assert this load state. Okay, so these states should be asserted in a proper time. For that, we are using synchronizer. Okay. Okay, then see here, after detect address is asserted, then see in our FSM we will receive where to see the last signal of the FSM, that is load first data. It will be given to the register. Okay, so this register will load the first data. Okay, see here, it will based on the address. Let's for our example, let's consider 342. Okay, so it is going to load the data. Okay, first it will load the address and it will load the data and it will be given to this 342. Okay. Okay. After that, what happens? Load data will be given to this register. Okay. See, then what this register do? It will load the actual data to this 342. Okay. Then after that, load after full. Okay. For this, okay, for this, see here, if our T4 is full, okay, that is before this load after full, what should be indicated? This P4 should indicate that this P4 is full. For in our example, I am taking, okay. In case if our P42 is full, what happens? Our P42 will assert this full 2 signal and it will be moved to this synchronizer. Okay. So now what will happen? The synchronizer will assert this P4 full signal. Okay, see the first signal of this synchronizer, it is P4 full. It will be asserted and it will be moved to this. Okay, it will be moved to this FSM. Okay, so now what happens? This full state in this P4, see here, full state in this P4 will be asserted and it will be moved to this register. Okay, now our register come to know, okay, our P4 is full. Okay, so now what happens is, if our P4 needs some more data, that is very minimal amount of time, see this low packet, no, this low packet valid will be asserted and some that remaining low data will be moved to this P42. When means, see, there is a signal called load after full, no? After asserting this signal, our register will make this load low packet valid to high and our data will be transferred to the particular P4. Okay, that is in our case P42. Okay, then once again our operation is done. Okay, that is once again all the process done. Once again our P4 will be moved to this address. Okay, this same state, that is direct address state. Okay, once again after completing the process. Okay, it will move to the same state. Okay, that is when it come to know in the sense, see, in our register there is a signal called parity done. Okay, so after checking all the parities and sending the data to the P42, okay, to the destination, our parity done signal from the register will be asserted and it will be moved to this where it is moving, see here, and it will be moved to the where, see, it is moving to the FSM. Okay, so after our FSM come to know, okay, parity done signal is received, once again it will start with the direct address. See our actual address, once again our parity done is asserted, it will move once again and it will start from decode address. Okay, so is there any doubt as of now? We will brush up tomorrow once again first, but as of now in today's session, is there any doubt what I explained here? the signals in this architecture? Is there any doubts? No doubts, sir. You may have some, how to tell, wait 1 second. Yeah, you may have some unclarity, like you may not get some. Even I no, no, I will refer. Okay, it is not wrong. Okay, I will refer and I will tell you. See, for example, yesterday someone asked, no, at that time, yeah, I explained this, but yeah, I referred. Okay, I referred, and right now I changed. So same. Okay, if you ask some doubt, if I know, I will answer. Okay, even I don't know, no problem. I will refer and tell. We have some other seniors here. Okay, some other staffs also. I will refer and tell. Okay. No problem. But I did this project, so I have some knowledge on this, so I can answer. But even though this, apart from my knowledge, I will refer and tell. No problem with that. So please, if you have any doubts, you can ask. Or if you have no doubts, you can tell no doubts, so that we can move to the FSM. So if you is it clear as of now?
Sir, I need
Yeah.
to go through this all once
Okay.
because today's session is a bit lot. So, sir, can you please share the PPT? We didn't
Yeah.
get
Actually, oh, you didn't get. Okay. Then I will share. I thought that okay, you might receive that PPT. I thought like
No.
you received that PPT and you are going through. Okay. I will send.
And
Actually,
this
yesterday's
today
session
and
is received.
yesterday's
No,
session.
yesterday's session
Yesterday
is
and
not
today.
yet received. Or
No, not
actually,
shared.
I think we have shared the yesterday's session, not yet shared that. Okay. I will share that yesterday's session. Actually, it is shared. I think check it once. If it is not shared, I will share, and I will share today's session also, because today we come across with some important topics. So I'm starting from here, and no problem. I will send the PPT. Go through it once. We will see once again. Okay, we will see the overview once again, and we will discuss tomorrow. We will see the FSM and the architecture. And you also refer from your side. And if you have any doubts, please ask. Okay.
Okay, sir.
Okay. As of now, if you have any doubt, you can ask or you can leave. Thank you.